So my name is Mano Marks. I'm a developer advocate here at Google, and it's my job to help external developers who are working with the Google Maps API and all of our mapping technologies. So I'm going to talk to you today about beautiful vectors. If you were at Strata and saw my talk there, you can go get some more food. This is going to be pretty similar to that. But general theme, talking about moving beyond our base map. Looking at ways in which you can combine new innovative technologies with Google's base map. Okay, so one of the things that I like to start off with is this one. This is the image doesn't come out that well on the projector, but it's a Babylonian map of the world. And it is one of the early maps that we've been able to discover. And you'll see on it there's actually a map and there's text. And I like this combination because it shows that mapping has always been about both visualization and data. I'm going to jump ahead to 1997. This is the first, or one of the early web map viewers. This is a tighter data viewer from 1997. This is one of those, if you're old like me, if you actually remember times before the internet, you can remember that in order to zoom in, you had to refresh the page or refresh the frame and get a new image. There were no slippy maps, none of this Ajax-y stuff. That was back in the day when we had the image tag. And then jump a little bit farther forward to, I want to say 2005, Pete, keep me honest, 2005, Google Maps launches, and apparently we only had North America and the United Kingdom, which I guess that's all we have map data. But the interesting thing about that is the start of the modern slippy map. So this is the first time that we had maps that you could load up the map and then it would just stay within the page. You didn't have to refresh the page or the image or anything. And it started what is now the basis for Google, for not just Google, but for all web mapping technologies, which is the tile image server. So basis for maps has been since 2005, and actually since before that, is you have your raw data, which then gets combined into a geodata store. It comes in from a lot of different sources. Our early data came from Navtech. Right now we use TeleAtlas, MapMaker, a whole variety of different services. We combine it into a common format into our data store. And then when the client computer makes a request, we send out map tiles. And it's done in an image pyramid so that when you are at low zoom levels or you're far away from the map, you see low resolution tiles. And then as you zoom in, you see higher resolution tiles that cover smaller areas. So the basis for mapping has been images, image technology sent out. It's the visualization. Now, one of the things that's interesting about this is that it's actually really efficient for the client, but it's very inefficient for the server. It takes up a lot of work to render them. And what a lot of servers do, Google doesn't do this, but what a lot of servers will do is they actually pre-render a set of tiles, say once a day, once a month, however often they're refreshing their imagery. Google actually used to do that. Right now we actually render the tiles on the fly. So if somebody requests a tile, we look and see if we have something cached from the last couple of minutes, and otherwise we generate a new tile and send it to them. So lots of server power. And what I'm going to talk to you about today is the start of how we are actually moving this part out of the serving infrastructure and moving it into the client itself. So what I'm talking about fundamentally is HTML5. And I don't know how many of you are familiar with this, this trend in browser development. But the idea is that there's this suite of technologies that are moving the power of more things we expect from desktop applications into the browser. So think back to the early 90s, those of you who have gray hairs like me, and the internet comes around, and there's this new interesting thing, but it's very scary for IT administrators, for people who build computers. Because what happens is, your computer connects to some other computer somewhere else in the world, and downloads information, and prints it onto the screen. And it's actually kind of terrifying for anybody who's worried about security. And as we've learned, that this has become the primary vector for which people do attack other computer infrastructures. So people were very scared of this possibility. So browsers were deliberately limited. They were what's called sandboxed. They had very little access to system resources, and nobody thought that you needed much more than that, because the first web pages, think about it, the hundreds of web pages that you could browse that had great scientific information on them. And it was a revolution in information sharing, but it was also something that was very frustrating for those who who weren't in the IT industry, because they thought, well, how come my web pages can't do more? So in the early 2000s, we saw, Ajax as the development of high-end JavaScript and XML and other formats-based technologies, which took advantage of all the capabilities of the browsers and really pushed them to their limits. So people started to expect things like Gmail and Google Maps and rich internet applications that previously they'd only seen in Flash or in their own in desktop applications. And browser developers and web developers started to want more. So in the mid to late 2000s, they started developing a new set of technologies called HTML5. And the ones that are relevant to us particularly are Canvas and WebGL. But there's some other things, getting things like access to the file system and graphics cards and WebSockets, which allows a browser to directly communicate with a server and keep an ongoing connection rather than having a single one-off connection. Offline storage, web workers that could perform tasks in the background. So how does that become relevant to us? One of the things that we start being able to do, I don't have this demo actually running on my system at the moment, but this is using Canvas. So Canvas is a widely deployed technology. All modern browsers have access to it. You create Canvas tags, and then there's ways to manipulate them, manipulate the graphics in them. There's a library called HeatmapJS. And what I'm showing you here is actually a screenshot of 5,000 earthquakes of magnitude 4.5 or greater, rendered as a heat map on top of Google Maps. This is it's an open library called HeatmapJS. I'll have a link at the end of the slides. The idea here is that data gets pushed into the browser and then rendered as imagery. So then analyzed and something is done. And so that's what, when we talk about vector data and vector mapping, that's what we're talking about. Instead of rendering images and sending them down to the browser, you send down the raw data, and then the browser figures out what to do with it. So what I'm going to spend a little bit more time on than this, though, is WebGL. So this is this is something that I developed. This is a mashup, and this is building footprints in San Francisco. Now, this is Data SF produces a lot of open data. What I did was I took a shapefile, converted it to KML, and then stripped out all the coordinates, and ended up with 6 million vertices. So raw data, there are 6 million points on this map. And this is actually a live mashup. You can see as I zoom in, it's actually rendering continuously. So this is using WebGL. Now WebGL is based on an older standard called OpenGL. It's actually a mobile version of it, so OpenGLES. And basically what it's doing is it's taking advantage of one of the most powerful processors on your computer, which is the graphics card. And it literally is just rendering it on the graphics card and sending it back to the browser. So I sent this down, and this is actually rendering frame by frame. So every second you're seeing continuous rendering. It's re-rendering it, re-putting it back on the screen. And that allows you to do some really interesting things, none of which I have done on this map. My colleague Chris Broadfoot had a little bit more time, and he took a sample of data. This is from a company called Uber. Uber does a application that's used by taxi cabs. I think it's taxi cabs or card services, I'm not sure which. And if you can get this app, and you can download it, and then you request a cab, and then the cab comes, and you can actually see in real time where cabs are. And so they're basically on an iPhone or an Android device tracking themselves. Well, you can imagine this is a tremendous amount of data. And so Chris took a snapshot, I think it's 1.2 million points of data. And this is the basic format that it came in, tab separated values. And he produced this. I'm going to re-render this. So this is a Google Maps mashup. Now, it's a little dark. I don't know how long this goes. Let's see if I can. There. That might be a little bit better. Is that better? Okay. He used Google Styled Maps, the Styled Map API, which is part of the Maps API, to render this sort of dark version. I'm going to reload this just so you can watch that happen again. And he rendered this 1.2 million points, which took place over the course of one week's worth of data. And you can see it's actually drawing the data in as I'm talking. And those are each individual points. So he did some optimization on this and allowed the application using WebSocket to just calls to the server and says, send me the next 1,000 points, send me the next 1,000, send me the next 1,000. And so you can see it growing over time. Well, when I said on my mashup I wasn't doing any of the interesting things, one of the interesting things that you can do is you can actually then manipulate the data. So you think of a map tile that comes down to you, and it's actually a pretty static thing. It's an image. Not a lot that you can do with that image. There's a lot of data contained in every little point. You see all the different roads and all that stuff. You can't actually do much with it. But here we can programmatically interact with the data. Here I'm taking different time slices. This is data from, I think, just 8 minutes or something. I don't remember which buttons actually signify which. But basically taking little slices of the data and programmatically interacting. Now it can actually do this. So you remember what I said about WebGL is rendering this frame by frame. That means every second you're seeing between 10 and 60 iterations of it's refreshing to the screen. So fast that you don't even really notice it. Your TV has usually, I think, what 10 to 20 refresh. High-end video games, they aim for 60 frames a second. So it really depends on your graphics card and how much you're taxing this. But you can get up to 60 or more frames a second. So it looks almost natural the way things animate. And here I can just programmatically interact with it. So this gives me the ability to do really interesting things. Look, I can zoom in here, and where it's brightest, I can see actual hotspots of where the taxis are, where they spend time. And you can make inferences about those things like, you can see it here, if you know San Francisco, this is Market Street. You can see there that on Market Street, they probably spend a lot of time in traffic, slowing down. There might be time they actually spend stopping to pick people up. It gets even more extreme over here. This is downtown San Francisco. And if I reduce the time frame, I can actually see how that changes over time. And you see up in the upper left, the actual time slices are changing. But I can do more. I can change the opacity. That is how opaque the different points are. I can blur them or unblur them to get more of a fuzziness, which can give me a greater sense of the general areas things are. I can change the size of the points. And I can also take off decay. So what he did was he actually, points are darker in older rides. So what he does is sort of over time, he sort of fades out different points. And that's really useful when he does speed coloring. So you can see here also speed coloring. So points that are red show you where where things are slowest. Now, anybody knows San Francisco, this is exactly what you would expect, right? Things are going to go the slowest in that downtown area. So all of this is being done with the same base set of data. The data is being sent down with certain attributes and position locations, and that's it. And then the application makes choices about how to actually display it. So it's really, I think, a very exciting new technologies. Now let me give you one more view of this data. He did a heat map demonstration here. Same kind of thing. And I don't want to take up too much time, so I'm not going to go too much into it. But doing just sort of a very similar thing by blurring the points even more so that they're bigger, and then when the colors overlap, you get different concentrations. Yeah.
So I'm curious, like, how does WebGL play a role here? Like, where does he use WebGL to draw the maps, or
to draw the overlay on top of the map?
Overlay on top of the map.
Right. So
not using Google API.
Well, the Google Maps API gives you the base map. It gives you the thing underneath it, plus a bunch of additional services that you can use.
Okay.
This is sort of taking the overlays to the next level.
Okay. And okay, so the previous example, the canvas example.
Yeah.
That is, so you say it sends like the raw data. It doesn't send the static images when you do a canvas.
Right, the same as with WebGL. The server sends raw data, and then the browser draws it.
So is that a different kind of API? Because the one that's out there, the JavaScript one, how does that work? That sends static files, images.
It sends static tiles in JavaScript container. Yeah.
The one you're talking about, this is like a different API? Is that what it is?
This is custom mashups that are being developed on top of our APIs. So basically what we're doing is we're using our base map. This is the JavaScript API. That's what gives you the map. And then we're loading in an overlay, a ground overlay on top of it that's rendering in WebGL. And the other one was rendering in Canvas.
So you have to position all of those by CSS then? Like all of those points and everything? You know, all the data?
No, the Google Maps API actually gives you the capability of adding custom overlays. And so it's just taking advantage of the fact that the Maps API is treating this as an image. And what you do is you find a way to, you have to map your data to lat long. So you map pixels to latitude and longitude. It's called world coordinates versus latitude and longitude coordinates. So you find a way to do that mapping. You tell the API how these are mapped, and then it maps them on top of using.
Very cool.
Yeah.
Are you going to put it up on?
Well, I'm going to get to that. I'm not quite there yet. So. I had this one in case those didn't work. I covered all this, so there's a few things you can do for optimizations. So you can use typed arrays and array buffers. You can use, I have 5 minutes? Okay. There's sort of precision versus size trade-offs. So when you're doing really precise geographic coordinates, they're often floats, and they, in programming terms, they get to be very long. The longer they are, the more memory they take out. So you make some trade-offs on that, and stream in the data versus via WebSockets. Just a couple of notes. If you have an Android device and it uses, you have Google Maps on it, you're already seeing a version of vector mapping. So it already does this, sends down the vectors, and then the map re-renders it. And these are basically two different views of the same kind of data. This is a map view, and you see it's in this sort of 2.5D, you get this perspective view, and this is the navigation view. It's the same data sent down, and you change the way the view works. So we haven't published any of these samples yet. Let me emphasize something though. WebGL is still a fairly experimental technology. It's supported in the latest versions of Chrome, Safari, and Firefox. It's not supported in IE yet. Just put that out there. It's also not an easy thing to develop with, so recommend using different frameworks. At the WHERE conference, which is coming up April 2nd to 4th, which used to be called WHERE 2.0, my colleagues Josh Livney and Brendan Kenny are going to be doing a talk where they're going to be addressing this, and at that point we'll probably be releasing some samples. And if you want to go to WHERE 2.0, there's a registration code that will get you 25% off. So Goop 25. So we hope to see you there. And then I'll probably put these up. I'll probably post this to my Google Plus in the next day or so. These slides that'll have links to getting more information. So I think I have time for a question or two. 2 questions. Yes.
Just curious, on the back-end side, when you collect the data, on the sampling, how many taxi cars, and how do you deal with the noise if we apply to nationwide service?
In this case, what Chris did is he got a sample from Uber. They pre-processed it and given it to him.
Okay, then we're looking at.
Yeah, and then he had 1.2 million points, and then he did some more processing on it to send it out. So these are kind of canned samples. By the way, if you go to maps.google.com and turn on the MapsGL experiment, the entire map is running this way. So it's all being rendered in WebGL. Okay, we have time for one more question. Yes?
Do you have to do simplification and pull out some line features before you send it at lower zoom levels? Do you do that dynamically, or is that cached somehow?
You can do that. You don't have to. I didn't, and my sample takes up a lot of time to load. So the way that Chris handles that is he actually sends down data in packets to the browser, in like thousands at a time or 10,000 points at a time. Once it's being pushed off to the graphics cards have tremendous capabilities to do this rendering. Also, WebGL can detect when something is not on screen and will automatically not render it.
Right, but for instance, for the MapsGL experiment, when you're looking at the whole US, you can't send out every row.
No. And you'll see as you zoom in MapsGL that you'll get higher resolution data. Yes.
So you still have a server process that's simplifying your vector data?
Yes, you do. You just don't have to render it as a map tile.
Sure. Thank you.
Sure. Okay, I think my time's up. I'll be around the rest of the evening.